So welcome in our today's lesson. I remain teacher Simon Peter. We want to geometrically represent complex numbers on a Hagan diagram. So they have given us some example here. But given that the complex number z is given by 1 minus I, then A represents z on the Hagan diagram. Then B, find the magnitude of z. Someone can call it modulus, somebody can call it length. They all means the same. And have z. This is the argument of z, the principal argument, the required argument. Therefore, before we go and do this question, let us get to know something little, what the Hagan diagram means. Hagan diagram, this is representation of complex numbers on a xy plane, which will be, if I draw my coordinate axis like this, realize that if I have a complex number z equals to a plus ib, what I do, I plot it as a vector ab. So when I plot this on my graph, if this is a, that is b, this is where I will plot it. Realize that this is where my z is located. And this is my real axis. Real axis replaces the x axis. And then imaginary axis replaces the y axis. You find that if this is your z and where there is AB, you make a straight line that goes to that point. Then you make an arrow on top. You join using dotted lines from the imaginary axis and using dotted line from the real axis. Then realize that the length between the origin, the straight line between the origin and the z you are plotting, that distance or length is called the modulus, and it's always represented by I. Then the angle the line makes, the complex number makes with the real axis is given by theta, which is called the argument. Then you realize that if I want to get this R is the same as the modulus of z. It's just root of a squared plus b squared. Because this from here to here, this is 0, from here to here is a, here to here is b. So square root of a squared plus b squared gives us the modulus. Then when we want to get theta, which is the same as z, argument of z, this is given as tan inverse of b out of a. The value you get, that is the principal argument. And principal argument or have z is given from the range of negative 180 degrees less than or equal to theta, less than or equals to 180 degrees. Therefore, having this knowledge in our mind, this is what we call the Hagan diagram. Therefore, having this knowledge in mind, we can now solve this question. The question is saying, given that the complex number z equals to 1 minus r, given by 1 minus r, represent z in the Hagan diagram. Then find modulus of z and have z, argument of z. Therefore, if our z is 1 minus I, therefore, if I draw my real axis and imaginary axis, I realize that this is the same as 1, negative 1. I plot those points. After plotting Because we realize that this is the 1, then negative 1 can be around there. You have to plot it. Let me make it bigger. I put negative 1 to be around there. Negative 1, negative 1, negative 1. It will be there. Then I draw a straight line from the origin. Then I make my arrow there. This becomes there. Z. We want that we join. We also join the dotted line. If we want to get the argument, we put theta there.
Yes.
If our theta is there, we can make this a right angle. Then this will be R, isn't it?
Yes.
R is the modulus or length of Z. So this we have represented Z on the Argand diagram. Let us go and do our B part of the question. This was A part. B part they are saying find the modulus of Z.
Yes.
Modulus of Z is the same as R, which is given by square root of, because from here to here is negative. This length is what? Because R is given by A squared plus B squared root, isn't it? Whereby my A will be 1, my B will be negative 1. Is it okay?
Yes.
Not R. R will be equal to 1 squared plus negative 1 squared, isn't it? Then my R will be equal to
root of 2.
In modulus or magnitude is in units.
Yes.
Length is measured in
units.
Then they want us to get half of Z. Want the height, the value of theta. Then if I want to get my theta, which is the same as half of Z, is given by tan inverse of 1 all over negative 1. This one we just say 1 over 1.
Yes.
We don't include the negatives when we are getting. Negative is just to show the location. Is it okay?
Yes.
Theta, which is half Z, is equal to 45
degrees.
So, at 45 degrees, you realize that when we come here, if we put 45 here, we can read from here up here, but this is wrong, isn't it? If you read from here up to here, wrong, because argument should be given from negative 180 degrees less than or equals to theta less than or equals to 180 degrees, and it must be in radians, isn't it? In terms of pi. To convert it to radians, we change it to pi, isn't it? So realize that I have to read from the negative direction, because if I read from here up to here, you go up to, it is beyond 180, isn't it? So in the positive direction, does not apply. Let us try in the negative direction. Negative, this is just negative 45, isn't it?
Yes.
Therefore, my theta, instead of 45 degrees, I change it to
Negative
45 degrees. But this is not yet the answer. The answer should be in radians in terms of pi, isn't it? Therefore, half of Z is nothing but negative 45 divided by 180 degrees pi, which is negative pi over 4. Just like that. For those who don't know how to convert from degrees to pi or from degrees to radians, we are going to say 180 degrees is equivalent to pi. Is it okay? If 180 degrees gives us pi, what about negative 45 degrees? Negative 45 degrees will be equal to pi divided by 180 times negative 45 degrees. By 45, 1 by 45, 4. Our answer is negative pi over 4. And that is the answer. So what you should mark in mind, R is the argument, is also called, R is the modulus. We also call it magnitude. Somebody will set for you as length. You must know it means the same. The unit is just units for length.